Good afternoon, everyone. I am Aripriya KN and welcome to the project presentation. Our project title is Human Action Recognition in Surveillance Camera, and we are from batch number B12. My team members are Kirti S, Mamata R, and Pawan Kumar V. We are working under the guidance of Anand Kumar sir. Our reviewers are Ranjit sir and Kavya Priya ma'am. Let's move on to the introduction part.
Hello.
Yes, sir. Let's move on to the introduction part. Currently, video technologies are facing several challenges and difficulties. Hello. Hello. Can you hear me?
Yes, sir, Priya, you can continue.
Thank you. Let's move to the introduction part. Currently, video technologies are facing several challenges and difficulties. The main aim is to develop an automated system for human action recognition is to identifying persons and the actions performed by them in a given video. The primary goal of human action recognition indicated analyzing input images or videos for ongoing human activities. Action in the sense, someone is running, walking, jogging, and so on through the surveillance camera. Now Mamata will be continuing the further presentation.
Now I am explain about the objectives of these projects. First one is identification of human actions like running, walking, etc. in an image or video. The second one is classify the important sequence of the video, and the importance depends on the types of actions or objects must be summarized, whether it is a hand waving, clapping, etc. The third one is this approach is tested on our data set by extracting the particular sequence of each person in the video and apply the algorithm. Next, my teammate Pawan will continue the existing system.
Thank you, Mamta. Now I explain the topic is existing system. The existing method uses the entire video region to extract the MHI of person action, which is not tolerated when the scene contains many people acting. For video surveillance systems, human body is incomplete in some cases, which represent a challenge for human action recognition. For that, we use just the region where there is motion. So our representation of data corresponds to the sequence of human body regions during this motion in the video. The new data is just an extraction of the region containing the human body and not all the scenes. Next topic is explaining the Kirti.
Now I'm going to explain the proposed system. We proposed a new approach for a combined multiple human action recognition and summarization technique. It starts detecting human bodies using a background suppression method approaches by applying some pre-processing technique and learning process in order to cope up with the various occlusions and crowded scenarios. The action classification is performed using the two methods that are cosine similarity measure for comparing the current actions with the training data sets, and the second one are convolutional neural network model to classify action of images in the input. Next, the literature survey. The title of the paper which I was referred was Human Action Recognition Approaches with the Video Datasets. The authors are Tansel Ozer, Deguselin, Reda Alzagi, which is published in the year of 2021 in the Journal of International Conference on Technology and Engineering. Coming to the detailed survey of the literature survey was, human action recognition has recently attracted considerable attention This has been triggered by the rapid development of advanced technologies and learning methods. The scope of survey covers a variety of human action recognition studies which involve the classification and prediction of activities and actions. Their features, similarities, and difference have been highlighted. As a result of this study, taxonomy information has been produced. The accuracy rates are method have been examined and the condition under which each other method is applicable and preferred has been explained. This survey highlights various aspects of the most popular methods and datasets related to the human action recognition. The datasets are used for these surveys are Weisman datasets, which was collected by the Garlic. It contains 10 different actions like running, walking, skipping, jump forward, jump in place, waving the hands, and the datasets also contains the 90 videos also. Neural network based methods are often chosen to facilitate the realization of human action recognition, proved to increase the performance. The survey covers two neural network based methods, namely convolutional neural network and recurrent neural network. Most common human action recognition methods are realized using the supervised learning. However, it is also important to analyze the recognition process. Instead of processing each given frame faster, consists of a combination of a model that includes the details of the action and a model that captures the changing scenes over the time. It aims to cover the entire video at low cost and hence avoiding duplication. The currently used methodologies are mostly based on deep neural networks. Higher accuracy values have been reported with a deep neural network based architecture. Coming to the conclusions of the paper, we analyzed the encountered approaches into five main categories. We have closely investigated their architecture by concentrating on the methods that we have considerable. And coming to the paper two, the title was an extreme learning machine and action recognition algorithm for generalized maximum cliché problem in video event recognition. The authors are R. Kavita and D. Chaitra, which was published in the year of 2021 August in the Journal of International Conference Series of Advanced Scientific Actions in ResearchGate. In this, a video event classification exhibit much capabilities in applications, including content-based video recovery. Identification of manual activities in video has remained a potential topic of research in the computer vision field owing to its significant theoretical importance in terms of research and widespread real application potential. To address the difficulties of low contrast videos and identifying the action group in videos, a comprehensive human activity recognition model must be created, which suggests a combined use of histogram equalization, image enhanced technique, and spatio-temporal main attribute model for low quality video sequences. Extreme learning machine in the form of a new single hidden layer feed forward neural network. The implemented system designed the new approaches for action recognition and semantic concept detection in complex vision. The surveillance videos are taken as the input. Various features and descriptors are extracted from the videos and applying features encoding. The object detection is performed by the ELM for generating a feed-forward model for event recognition accurately. The conclusion of this paper was to decrease the computational overhead and precisely decrease the feature information loss and vector of locally aggregated descriptors based features encoding is performed. Using an extreme learning machine, action recognition is performed accurately and experimentally results are indicates the implemented system yields improved perform in comparison with the available system in terms of metrics such as accuracy, specificity, and so on. The next presentation will be continued by my teammate Mamta.
Thank you. In the paper 3, the title of this paper is Recognition of Human Action by the authors are S.R. Vidya and T. Jayashri from International Journal of Research in Engineering and Science. This paper presents a hybrid strategy for efficient classification of human activities from a given video sequence. In this paper, there are 4 problems. The first one is according to Christian's called survey used local space-time features capture local events in video and can be adapted to the size, the frequency, and the velocity of moving patterns. In this paper, we demonstrate how such features can be used for recognizing complex motion patterns. According to the Ronald Poppe, vision-based human action recognition image sequences with action labels. Robust solutions to this problem have applications in domains such as visual surveillance, video retrieval, and human-computer interaction. The task is challenging due to variation in motion performance, recording settings, and interpersonal differences. According to the Maxime Devanne Hajem Vanaso survey, 3D human action recognition is an important current challenge at the heart many research areas lying to the modeling of the spatio-temporal information. In this paper, we propose representing human actions using spatio-temporal motion trajectories. According to the Xiaowei Gu survey, employ handcrafted and deep learning techniques for human action recognition. To resolve these problems, proposed a hybrid methodology. The proposed method is divided into 4 steps. First one is frame acquisition and enhancement. Second one is segmentation of moving region. Third one is feature extraction and fusion. Fourth one is feature selection. In this, all video sequences are divided with respect to the subjects into training set and validation set and a test set. A new set of fused features are extracted from sequences using local binary patterns with histogram-oriented gradient. The classifier were trained on a training set while the validation set was used to optimize the parameters of each method. In this method, KTH datasets are used for training the K nearest neighbor classifier for human classification and for testing. The frames are tested against the KTH using confusion matrix and KNN classifier. KTH human motion dataset contains 6 actions in this paper: walking, jogging, running, boxing, hand waving, and hand clipping, performed several times by 25 different actions. And 4 different scenarios are used. First one is outdoors, second one outdoors with zooming, third one outdoors with different clothing, and last indoors. There is considerable variation in the performance and duration and somewhat in the viewpoint. The backgrounds are relatively static. Apart from the zooming scenario, there is only slight camera movement. This paper is concluded with we detect and classify human actions by extract the corner and block features with suitable learning algorithm. And we could observe that K nearest neighbor is overcome other classifiers, and also the KNN performance is faster than others. And the big challenge we face here is classify the similar classes where the difference in accuracy of classification of KNN between similar and non-similar almost 12% higher than other classifier like SVM. That coming to the paper 4, the title is Human Activity Recognition Using Inertial, Physiological and Environmental Sensors by the authors are Florent Dembrosi, member of IEEE, Graziano Paravadilli, senior member of IEEE, Azra Bihora and Paris Rashidi, senior member of IEEE. Human action recognition systems have become a growing research area in the past decade. achieving impressive progress. In particular, sensor-based human action recognition have many advantages compared to the vision-based human action recognition methodologies, which pose privacy concern and are constrained by computational requirements. Activity recognition algorithm based on machine learning and deep learning are becoming central in human activity recognition. In this paper, data for training and testing human activity recognition algorithms is typically obtained from two main sources. First one is ambient sensor. It is environmental sensor or video cameras positioned in space specific point in environmental. Second one is embedded sensor. It is integrated into personal devices such as smartphone and smart watches or integrated into clothes or other specific equipments. When developing human activity recognition based application, the first step is to determine the type of sensor and device that is used to collect the data. Second step is to determine the details of the data collection process. The third step includes identifying the appropriate machine learning model and training the model. Typically, a supervised machine learning model on annotated data, that is model selection and training. In the final step, the model is evaluated in terms of the activity recognition matrix. In this, the accelerometer sensor are used because they have shown excellent results in human activity recognition applications. The data sets are largely based on accelerometer, gyroscope, and magnetometer sensor data. Most of such sensors are embedded into smartphones and smartwatches, and the number of activities in these data set ranges 2 of 202 to 33 of 205. The most common studied activities are walking, running, sitting, standing, walking upstairs and downstairs, etc. We concluded this paper, the main objective of human activity recognition algorithm is to recognize human activity based on data by variable and environmental sensor. The recognition of these activities mainly based on classic machine learning and deep learning algorithm. Next, my teammate Haripriya will continue further papers. Thank you.
Thank you. Next, paper number 5. Title is A Deep Genetic Algorithm for Human Activity Recognition Leveraging for Computing Frameworks. Authors are R. Raja Subramanian and V. Vasudevan. Ambulatory healthcare services have become prevalent in today's world, where many patients suffer from pandemic diseases. Physically or mentally challenged people, childhood and elderly people requires continuous monitoring. It is always proactive in such people's health. During isolation, these categories of people have higher health risk with respect to their activities. Aged people and physically challenged people cannot recover themselves from some accidental movements. In addition, people suffering from pandemic diseases requires to have a self quarantine. Such isolation has various mental effect on the patient. Hence, it is required to monitor and safeguard the patients. Here, you only look once algorithm version 3 is used for human detection model. The video frame categorized as changed in change detection phase will be inputted to the activity recognition model. Surveys are done on various state-of-the-art deep learning algorithms for image inference. The performance of various ImageNet models, including AlexNet, VGGNet, GoogleNet, RESNet, are done and visualized that GoogleNet serves effectively with respect to the accuracy and time complexity. The GoogleNet consists of 9 inception modules with convolutions of different sizes to incorporate features at different scales. The fully connected layer is modified by the global average pooling strategy. This reduces the size of to incorporate feature maps from n-dimensional space to single dimensional space with respect to the parameters. To relate the GoogleNet architecture to the human activity inference model, the final softmax layer is augmented with an additional softmax layer. This new layer will have number of neuron equal to the number of activities under study. The activity of the previous video frame is omitted under consideration, taking into account of the evidence provided by chance detection phase, thus reducing the solution space. In this paper, they are selected 3 distinct data sets. One is Hollywood action data set. It is consist of 1,707 sequences of videos composing 69 movies. Here, 12 different activity included. They are stand up, sit down, sit up, run, kiss, hug, fight, get out of car, drive car, handshake, and answer phone. Second data set is KTH dataset. It is one of the standard dataset. The videos are captured from 25 objects, contributing a total of 2,391 video sequences with 6 activities. They are walking, running, jogging, hand waving, clapping, and boxing. Last dataset is University of Central Florida aerial camera, rooftop camera, and ground camera dataset, shortly called as UCF-ARG dataset. It is a multi-view human action dataset. The dataset projects 10 different activities from 12 subjects. It includes various constraints, including the ego motion, the lighting levels, and the variation in camera heights. 5 activities classes like walking, waving, digging, running, and throwing. Coming to the next paper, number 6, title is a combined multiple action recognition and summarization for surveillance video sequences. Authors are Omar Elharas and 4 more peoples. Human action recognition and video summarization represent challenging task for several computer vision applications, including video surveillance, criminal investigation, and sports applications. For long videos, it is difficult to search within a video for a specific action or person. Usually, human action recognition approaches presented in the literature deal with videos that contains only a single person and they are able to recognize his action. This paper proposes an effective approach to multiple human action detection, recognition, and summarization. The multiple action detection extracts human bodies, then generates a specific sequences for each one of them using motion detection and tracking method. Each of the extracted sequences is then divided into shots that represent homogeneous actions in this sequence using the similarity between each pair frames. In this paper, they are using CNN, HOG, and TD map for human action recognition. Using the histogram of the oriented gradient of temporal difference map of the frames of each shot, we recognize the action by performing a comparison between the generated HOG and the existed HOGs in the training phase, which represents all the HOGs of many actions using a set of videos for training. Also, using the TD map images, we recognize the action using a proposed CNN model. Action summarization is performed for each detected person. The efficiency of the proposed approach is shown through the obtained results for mainly multi-action detection and recognition. In this paper, they are selected distinct data sets. They are Wisman, KTH, UCF-ARG, UT interaction, IXMAS, and MHAD, and other types of video that are collected from movies in YouTube. Hollywood cannot be used for recognition action with the proposed algorithm owing to the complexity of the videos. Number of used videos for each action from each data sets are boxing, carrying, jogging, running, walking, hand waving, hand clapping, digging, and throwing. Further presentation will be continued by Pawan Kumar. Thank you.
I refer in this paper 7. The title name is Detecting Violent Robberies in CCTV Videos. By the author name is Giorgio Morales Danier de Lodge. It was published in 2019. The Journal of Visual Communication and Image Representation. The CCTV video surveillance through security cameras has become robberies in the public too difficult due to the fact of system require manual human inspection for violent robberies in CCTV videos. The major problems of robberies is the crime of taking or attempting to the anything of value by force. The surveillance is the monitoring of behavior, many activities are information for the purpose of information. Managing and directing can be included distance by means of electronic equipment such as CCTV, means closed circuit television. The challenges in the early days of action recognition using CCTV camera in the research of focused on the design of effective visual description based on the handcrafted local features powerful of encoding schemas. The contribution of this paper proposes an novel adaptation for framework called a semantic adaptation based on vector of locally max-pooled deep learned feature for action recognition using CCTV camera. The objectives of recently using CNN, convolutional neural networks have made great progress in the field of computer vision to capture the CCTV video have extended convolutional neural network to video action recognition task. The experimental have conducted on a Windows to based on machine with 8 GB RAM and having a i5 operating with the 2.4 gigahertz frequency. And then the conclusion in this paper, we propose a novel framework called SAVLMPF, semantic adaptation based on the vector of a locally max-pooled deep learned feature for action recognition. Now coming paper 8. The author name is Domain Learning joined with semantic adaptation for human action recognition. The author name is Junction Zhang Haifeng Hu. It was published in 2019. The journal is School of Electronic and Information Engineering, Sun University, Gargur, China. The major definition of the proposed a novel framework for action recognition, which is called knowledge adaptation based on this idea. The proposed framework consists of a three-part two-stream fusion network TSFN. Next one, vector of a locally max-pooled deep learned feature and semantic adaptation model. The challenges of knowledge adaptation in this section, we describe how to exploit the prior knowledge learned from data sets to optimize the target classifier based on the deep semantic representation of adaptation model. We discuss the convergence of the recognition strategy. The experimental result to verify the effectiveness of our SAVLMPF framework, we construct three couples of auxiliaries, domains, and target. the domains as mentioned before. Next one, conclusion. All through our boosters the theory of action recognition, there still exists a limitation in our work. We will try to reconstruct in the semantic adaptation model with deep network structures and make it be the trained end-to-end way. Thank you.
Excuse me, sir.
Yeah.
Sir, any questions, sir?
Can you tell me the implication of your paper?
Ma'am, we can't get you properly, ma'am. Excuse me, ma'am.
Can you repeat the question?
Oh, okay, ma'am. I will explain the implications of the papers, ma'am. In these papers, they use the histograms of oriented gradient and the temporal difference map for the implementation purpose, and they use the image processing techniques, ma'am. For our project, the paper which was explained by Haripriya is most related, ma'am. The title was Combined Multiple Action Recognition and Summarization for Surveillance Video Sequences. They use a convolutional neural network for image or object detection. Any other questions, ma'am?
No questions. That's it.
Okay, thank you, ma'am.
Okay.
Sir,
Yeah, what is the next phase? What is your plans?
sir, implementation, sir.
Like how do you start?
We are
What is your plan? From where do you
So
start?
we decided to use some data sets. We collected some of them, sir. From them, we use it. We need by using which methods we need to discuss with you, sir. Like CNN or artificial neural network, like, sir.
Okay. Okay. Thank you.
Okay, thank you, sir.
Can we end the meeting?
Yeah.
Thank you, sir.